Today we'll talk about breadth first search (BFS). So for a graph, there are many ways to traverse graphs. BFS is the most commonly used approach. So for BFS, we should start traversing from a head node and then traverse the graph layer by layer. So in this example, we start from head node and then we visit layer 1 nodes and then visit layer 2 nodes. Here this is a demo. When implement BFS, we should use a queue. Queue is a data structure which data first in and first out. So we start from the node A and we mark A as visited and in queue A, and we dequeue A, and for A, C, and E are the neighbors, so we mark and in queue C and then mark and in queue E. And we dequeue C, and for C, B and D and F are the neighbors, so we will mark and in queue B, D, and B, D, and F. And then we will dequeue E. So for E, its neighbors are already marked, so we continue dequeue B. B, its neighbors are already visited, so we dequeue B, dequeue D, and dequeue F. Now the queue is empty, so that's the BFS algorithm. Okay, let's do a practice. The problem is you are given a tree and having n nodes, and it's a poorly connected graph. It consisting of n nodes and n-1 edges, and the nodes in the tree are indexed from 1 to n. So we can consider node indexed 1 to be the root node of this tree. The root node lies at level 1 in the tree. You shall be given the tree and a single integer x. You need to find out the number of nodes lying on level x. Let's see the input. The first line is a single integer n is the number of nodes in the tree, and then the following n-1 lines consisting of two integers. It represents node A to B, the edge between node A and node B. And at the last line is the integer to represent the level. So in this example, it's level 2. We need to print all the nodes. We need to print the number of nodes on level 2. First, we need to read input. Use scanner system in. First line, first integer is number of nodes n. Then next n-1 lines are the edges between node A and node B. n-1. Int A then equal next int B next int. So we need a way to represent the graph. So we can use a matrix. The node is from 1 to n, so we can use index from 1 to n. So here would be graph A and B. B is 1. We use 1 to represent that there is edge between the node. But by default, it's 0. 0 means there's no edge. It's an undirected graph. So the last is the x, level x. Now we need to find the numbers of nodes on level x, and we need to do a BFS. Turns out BFS number nodes by on level by BFS. The parameter we need is the graph and level x and the node, the number of node n. So now let's implement the BFS. So first we need a Boolean array to track if it's visited or not. And we need a array of int to track the level. And the start node is 1. And we need the structure queue. So we can use a linked list in Java. And first let's put 1 to the put the start node to the queue and mark it as visited. And for level 1 is 1. Let's see. The root node lies at level 1, so it's level 1. While queue is, if it's not empty, then we need to pull the first element. And then we need to get the neighbors of this current node. neighbors of this current node from the graph. So it should be from 1 to n. So this is the neighbor. We need check. We need check if this is 1. If it's 1, then it's the neighbor, and also we need to check if the node is visited or not. So if equals 1 and visited, and it's visited, it's not visited, then we need to add this neighbor to the queue. And for the neighbor, the level of neighbor, so the neighbors are from current node. So the level of the neighbors should be current node plus 1. Level neighbor equals level current node plus 1. After we add the neighbor to the queue, then we should mark them as visited. So that's the traverse of the graph, and then we need to find the number of nodes on level X. So we can check the level here. Int result 0. If x equals 1, so we can return how many nodes? One node. And if level equals x, so then we add the number of nodes by 1. In this way, we can find the number of nodes. So at the end, we return the result, and here in the main function, let's print out the result. Okay, let's try to run it. Compile error, so let's check. Oh, visited. Oh, here is the int. No, balloon. There should be int, and here is, oh, here is 2. Okay, let's try to run again. Run answer because output is 0. So let's to check the code. Oh, here should be at not neighbor. Neighbor is 1, or this is the edge. So so this should be edge. If edge is 1 and visited node should be I. So this should be I. I is the current node. Is the neighbor of current node. So and level I equals level current plus 1. Visited I. And the level I. So let's try to run again. Yeah, the task is passed. So let's submit. Yeah, it's accepted. Thanks for your watching, and bye bye.